Welcome to Celebrity Investing, your go-to source for insights, tips, and updates on navigating the exciting landscape of personal and global finance. Please like, share, and subscribe for more exclusive content. This is part 2 of Regression Analysis Explained: Tools, Techniques, and Real-World Applications. Economics: How regression analysis drives economic modeling and forecasting. Economists rely heavily on regression analysis to understand and predict market behavior. By examining relationships between economic variables, they can create models that explain past trends and forecast future outcomes. For instance, regression models help in predicting GDP growth. Economists can evaluate how factors like government spending, consumer confidence, and exports relate to gross domestic product, GDP. Analyzing unemployment trends, they assess how education levels, industry productivity, and policy changes correlate with employment rates. Inflation forecasting. Regression helps identify how variables such as crude oil prices or labor costs impact inflation. These models are the backbone of strategic policy making. When governments or organizations need to decide on interest rates, taxation, or public spending, regression analysis provides the data-driven evidence they need. In essence, it turns economic fluctuations into measurable, actionable insights. Healthcare: the role of regression analysis in clinical research and decisions. In healthcare, regression analysis aids researchers and practitioners in making data-backed decisions that can save lives. By identifying relationships between treatment variables and patient outcomes, this tool provides clarity where intuition alone falls short. Key applications include clinical trials. Researchers use regression models to measure how new drugs impact patient health, accounting for factors like age, underlying conditions, or dosage variations. Disease prediction. Logistic regression is often used to predict the probability of diseases, such as diabetes or heart disease, based on variables like lifestyle and genetic factors. Healthcare cost analysis. Healthcare systems analyze how aspects like hospital costs, length of stay, and patient demographics influence medical expenses. Regression doesn't just help with answering medical questions, it improves operational efficiency. Hospitals use these models to predict patient readmission rates and optimize care delivery. By combining medical knowledge with robust statistical tools, healthcare professionals make better decisions faster. Social sciences: using regression analysis to understand behavioral trends. Social scientists leverage regression analysis to explore human behavior and societal patterns. It allows them to examine how various social, economic, and cultural factors interact to shape the world we live in. Here's how it's applied in this field. Understanding education outcomes. Regression determines how factors like class size, teacher experience, or family income affect student performance. Crime rate studies. Researchers study the impact of unemployment, poverty, and policy changes on crime trends. Public opinion analysis. Data from surveys can be analyzed to understand how media exposure, education level, or political affiliation influences public opinions. This data-driven approach translates observations into measurable relationships, helping governments, nonprofits, and policymakers tackle pressing social issues. It's like peeling back the layers of human behavior to see the why behind the what. Regression analysis offers clarity in a field often full of complex variables. Key components of regression analysis. To truly understand regression analysis, it's crucial to break it into its core components. These elements form the foundation of any regression model, helping analysts interpret data and make predictions. Below, we'll explore the essential building blocks that bring a regression model to life. Dependent and independent variables. Define dependent and independent variables with examples. At the heart of regression analysis are the variables it seeks to connect. But what are they? Dependent variable. This is the outcome or the variable you want to predict or explain. It changes based on other factors. Independent variables. These are the predictors or factors that explain variations in the dependent variable. Think of the dependent variable as a plant and the independent variables as sunlight, water, and soil quality. The plant's growth, depends on the quality of these factors, independent. Example: a marketing analyst studying sales might use weekly revenue as the dependent variable and advertising spend as the independent variable. In healthcare, if you're studying how exercise affects weight, weight is the dependent variable, while exercise hours per week is the independent variable. Understanding which variables belong in each category ensures your model is set up correctly, establishing a clear cause and effect relationship. Regression coefficient. Explain what regression coefficients represent in a model and how they are interpreted. Regression coefficients are the backbone of any regression model. These are the numbers assigned to the independent variables, indicating their impact on the dependent variable. In simple terms, a regression coefficient shows how much the dependent variable changes when the independent variable increases by 1 unit, while keeping all other factors constant. Example interpretation. Say you're analyzing the effect of advertising spend on sales. Suppose the coefficient for advertising spend is 2.5. This means for every $1 increase in advertising, sales increase by $2.50. If a coefficient is negative, the relationship is inverse. For instance, a coefficient of 0.8 in a transportation study might show that as gas prices rise, public transit use increases. Key takeaway? Coefficients aren't just numbers, they're actionable insights about how variables relate in real-world scenarios. R-squared value. Introduce R-squared as a measure of goodness of fit in regression models. R-squared, also called the coefficient of determination, measures how much variation in the dependent variable your model explains. Think of it as a scorecard for your regression model's accuracy. It ranges from 0 to 1. 0. The model explains none of the variance in the dependent variable. 1. The model explains all the variance, perfect fit, but this is rare. Example. An R-squared of 0.75 means 75% of the variation in the dependent variable is explained by the independent variables in your model. The remaining 25% comes from factors the model doesn't capture. While a high R-squared is desirable, it's not the only measure of success. Sometimes, a moderate R-squared combined with strong coefficients or a meaningful model is more valuable than chasing perfection. P-values and significance testing. Discuss the importance of p-values in determining the statistical significance of variables. How do you know if your independent variable actually impacts your dependent variable? That's where p-values come in. They test the statistical significance of each coefficient, telling you if the effect is real or just random noise. A p-value measures the probability that the relationship you're seeing happened by chance. It's typically compared against a standard threshold, often 0.05. P less than 0.05, the variable is statistically significant. It's likely influencing the outcome. P is greater than or equal to 0.05, the variable isn't statistically significant. Its effect may be due to random variation. Example. If you're studying how education level impacts income and the p-value for years of education is 0.03, you can be fairly confident that education does affect income. But if the p-value is 0.10, you might need more data or variables to draw firm conclusions. P-values keep your models honest. They ensure you're not chasing flukes or overestimating weak relationships. Always double-check them to verify your results hold up statistically. These components, variables, coefficients, R-squared, and p-values, work together to create a clear, interpretable model. Understanding them is the first step to mastering regression analysis. Stay tuned and continue to watch our videos to gain valuable insights into the world of finance. Subscribe, like, and share to continue your journey to financial success.